Now let us see what is a Buckingham's pi theorem. So Buckingham's pi theorem is also a method of dimensional analysis, and let us see the definition of Buckingham's pi theorem. If there are n variables, independent and dependent variables for in a physical phenomenon or experiment, when you conduct an experiment, you found out that these variables are involved, and if these variables contain m fundamental dimensions, we have seen what is a fundamental dimension, mlt, then the variables are arranged into n minus m dimensionless terms, and each term is called a pi term. So this is the definition of Buckingham's theorem. This can be understood only by you doing an example. So let us see the method. Let x1, x2, and x3 are the variables involved in a physical problem. Let x1 be the dependent variable, and x2, x3, and xn are the independent variables on which x1 depends. Then x1 is a function of x2, x3, and xn, and mathematically it is expressed as x1 as a function. This we have seen already in the case of a uh, Rayleigh's method. In a physical phenomenon, these variables are involved x1, x2 up to xn, and let x1 be the dependent variable and x2, x3 will be the independent variables. So it can also be written as function of x1, x2, x3, and x is equal to 0. See, above equation is dimensional homogeneous equation. That means dimensions of left hand side should be equal to dimensions of right hand side, which is almost 0 for all the fundamental dimensions. It contains n variables. So the physical phenomena, this experiment contains n variables. For example, you are doing an experiment and these variables, you know the number of variables. That is why that is that are the variables which are involved in this physical phenomena. This. So if there are m fundamental dimensions, see, if you take these n variables and out in these variables, there are three fundamental dimensions. Then according to Buckingham's pi theorem, equation can be written in terms of a number of dimensionless groups or pi terms, in which the number of pi terms is equal to n minus m. So that means you can write the equation like this: f of pi 1, pi 2, pi 3, and up to pi n minus 1. These are the uh, pi terms. These are this doesn't have any dimension. This is a non-dimensional terms. So Buckingham's pi theorem states that this equation can be converted to this equation. These are the pi terms which doesn't have any dimension, and the number of these pi terms is equal to n minus m. So if there are n variables and m fundamental dimensions, number of pi terms will be n minus m. And each of its terms is dimensionless and independent of the system. Division or multiplication by a constant does not change the character of the pi term, and each pi term contains m plus 1 variables. So that is very important. Each pi term is made by using m plus 1 variables, where m is the number of fundamental dimensions and is also called the repeating variables. So in the above case, let's take x2, x3, and x4 are repeating variables. If the fundamental dimensions are m, l, and t, that is equal to 3, then each pi term is written as, so this is how you write the pi term. Pi 1 is equal to x2 raised to a1 into x3 raised to b1 into x4 raised to c1 into x1. Similarly, pi 2 can be written as x2 raised to a2, x3 raised to b2, x4 raised to c2 into x5. Like that, it goes on like this. That means, in brief, you can see that x1 comma x2 up to xn is 0. That is a function of these n variables, and there are m fundamental dimensions. Mostly it is m, l, and t. If temperature is involved, you need to take k. Mostly it is 3. So that means this can be converted to pi 1, pi 2 and pi 3 up to pi n minus 1. Number of pi terms is equal to n minus m. And how to write this? How to find out this pi term? This each pi term can be written as you need to select 3 repeating variables based on the number of fundamental dimensions. So repeating variables, if you select this as x2 and x3 raised to x4, you can write a1, b1, c1 into x1. So these are not the repeating variables. So you can basically you can write it like this. So let us do an example and find out how we can establish the relationship between the variables using Buckingham's pi theorem. So method of selecting repeating variables. Uh, I told you, see first we will see what are, then we will do an example how to select the repeating variables. So we have seen earlier the repeating variables are x2, x3, x4. How to find these repeating variables? See, the number of these repeating variables is equal to the number of fundamental dimensions. And the choice of repeating variables is governed by the following considerations. As far as possible, the dependent variable should not be selected as repeating variables. And the repeating variables should be chosen in such a way that one variable contains geometric property, other variable contains flow property, and third variable contains fluid property. So that means the variables with the geometrical property are length, diameter, capital S. You can select any of these variables as a repeating variable. And variables with the flow property are velocity, capital V, acceleration, etc. And variables with the fluid property examples are density, viscosity, etc. The repeating variable selected should not form a dimensionless group. If you take it together, it should not form a dimensionless groups. And the repeating variables together must have the same number of fundamental dimensions. The number of repeating variables is equal to the number of fundamental dimensions. And no two repeating variables should have the same dimensions. That is, in most of the fluid mechanics program, the choice of repeating variables may be like it may take diameter, velocity, and density, or length, velocity, and density, or length, velocity, or viscosity, or diameter, velocity, viscosity, like that. Now let us do an example. Let us take this example. That means the resistance offered by a body is a function of length, velocity, viscosity, density, and this case temperature, it is the bulk modulus of air, bulk modulus of air. So you can write it like this function of, mathematically you can write it like this function of r l v rho mu k is equal to 0. So let us see what are the dimensions of these variables. So dimension of L is capital L, velocity is Lt minus 1, viscosity is ml minus 1 t minus 1, density is ml minus 3, and key, that is a bulk modulus, is ml minus 1 t minus 2. The bulk modulus is basically pressure divided by delta V by V. So the dimensions of bulk modulus is same as that of the stress or pressure, that is force by area. So it is ml minus 1 t minus 2. So let us see what the number of variables involved are 6, and the number of fundamental dimensions m is equal to 3, ml and t. You see, k is bulk modulus, not temperature here. So the number of pi terms is n minus m or 6 minus 3. That is, totally you have 3 pi terms. You need to find out 3 pi terms. And let us find out the repeating variables. How to select the repeating variables? So repeating variables, the first one should correspond to a geometric property, and second one a flow property, and third one a fluid property, that is density. You can take viscosity also. it is better to take density. So V corresponds to some kind of a movement, so it is a flow property. So this is how you select the repeating variables. You need to keep in mind that only. How to see. Mainly, first one it corresponds to geometric properties. Second one it should correspond to flow property, and this one should correspond to fluid property. Now let us write the first pi term. So pi 1 is equal to L raised to A1, V raised to B1, and C raised to C1 into a dependent variable. Here dependent variable is capital R, which is it is not a repeating variables. Capital R or the resistance. So dimensions of resistance is corresponds to force. This is a force offered. So it is MLT minus 2. You need to find out these A1, B1 and C1. And pi 2 is equal to L raised to A2, V raised to B2, rho raised to C2 into mu. And here also you need to find A2, B2 and C2. Note that these pi terms doesn't have any dimension. It is a non-dimensional term. And pi 3 is equal to L raised to A3, V raised to B3, rho raised to C3 and capital K into capital K. So let us find out the first dimensionless term. That is pi 1, pi term, first pi term. Pi 1, we have seen, you can write it like this. This repeating variable L raised to A1, V raised to B1, this is the second repeating variable, rho is the third repeating variable, rho raised to C1 into capital R. And you know, we have seen the dimensions of L, V, rho and capital R. And dimension of pi 1, you know that it doesn't have any dimension, so you can write it as m raised to 0, L raised to 0 and T raised to 0. So it is capital L raised to A1 into capital L T minus 1 whole raised to B1 and capital M L raised to minus 3 into C1 into ML T minus 2. These are the dimensions of R and all these variables. So if you combine this, if you add this, you can get that it is L raised to A1 plus B1 minus 3C1 plus 1 into M raised to C1 plus 1 T raised to minus B1 minus 2. And if you equate these two, you can get that A1 plus B1 minus 3C1 plus 1 is equal to 0. C1 plus 1 is equal to 0. Minus B1 minus 2 is equal to 0. So that means A1 is equal to minus 2. B1 is equal to minus 2. And C1 is equal to minus 1. So if you substitute this here, you will get pi 1 is equal to capital R by rho L square V square. So this is the first pi term, capital R by rho L square V square. And let us find out the second pi term. That means second pi term can be written as pi 2 is equal to L raised to A2, V raised to B2, rho raised to C2 into mu. So first three are the repeating variables and this mu is a dependent variable. Variable which is not a repeating variable. So you will select mu here. So pi 2, you know the dimensions are m raised to 0, L raised to 0, T raised to 0. And this is equal to, if you write the fundamental dimension, it is L raised to A2, LT minus 1 whole raised to B2, ML minus 3 whole raised to C2 into this mu. Dimension of mu is ML minus 1, T minus 1. This is equal to capital L into A2 plus B2 minus 3C2 minus 1 into capital M raised to C2 plus 1 into capital T raised to minus B2 minus 1. If you add this, you will get. So if you solve this, compare these two equations, you will get A2 plus B2 minus 3C2 minus 1 is equal to 0, minus B2 minus 1 is equal to 0, C2 plus 1 is equal to 0. And if you solve this, you will get C2 is equal to minus 1, B2 is equal to minus 1 and A2 is equal to minus 1. So if you write this here, you will get pi 2 is equal to mu by rho VL. So actually if you check that, you will understand that this is rho VL by mu, it is 1 by Reynolds number. And let us find out the third dimensionless term, that is pi3. So pi3 can be written as a repeating variable L raised to a3, v raised to b3, rho raised to c3, and the remaining variable is capital K, which is the bulk modulus. So pi3 can be written as m raised to 0, L raised to 0, t raised to 0. This is equal to capital L whole raised to a3 into capital L t minus 1 whole raised to b3 into capital M L raised to minus 3 whole raised to c3 into m L minus 1 t minus 2. So this is equal to, if you add this, you will get L raised to a3 plus b3 minus 3c3 minus 1 into m raised to c3 plus 1 into t raised to minus b3 minus 2. So if you solve the equation, if you compare these here, LHS and RHS, a3 plus b3 minus c3, 3c3 minus 1 is equal to 0. c3 plus 1 is equal to 0. Minus b3 minus b2 is minus 2 is equal to 0. And if you solve this, you will get a3 is equal to minus 2, b3 is equal to minus 2, c3 is equal to minus 1. So this is, if you substitute it here, you will get k by rho v square. See, k by rho can be written as velocity of sound square. So pi 3 will become a square by v square. So this is actually 1 by Mach number square. So this is another dimensionless term. So that means you can basically write function of pi 1, pi 2, pi 3 is equal to 0. And this pi 1 we have found out it is r by rho L square v square. Pi 2 is mu by rho vl. Pi 3 is k by rho v square is equal to 0. So r by rho L square v square is equal to 5 into mu by rho vl into k by rho v square. So it is r is equal to rho L square v square 5 mu by rho vl into k by rho v square. So this is another way of writing. And this can be written as rho L square v square into 5. This is 1 by Reynolds number, and this is, we have seen, this is 1 by Mach number square. So this can be written as rho L square v square is a function of Reynolds number and Mach number. So you can also write it like this. This is another function.